Hey guys, me again. So today I wanted to go over something that's big in my world: access control, burglar alarms, intrusion detection, and that's door contacts. And these door contacts are a simplified version of a relay. And I'm going to show you what I mean right now. So these are all recessed 1-inch door contacts. Let's go over each one of these. So this is the simplest kind. This is a single pole, single throw contact. It has 2 wires coming out of it. A single pole, single throw contact has a common and a normally closed or a normally open other wire, and that depends on how you look at it. All right, our next kind of contact is going to be the same thing, a 1-inch contact, but yet now we have 3 cables. This is a single pole double throw contact. So you're going to have a common. One of these 3 wires is going to be common. One's going to be normally open. One's going to be normally closed. And I'm going to show you how to test that coming up. And then your next kind of contact here is it's going to have 6 cables on it. So much like a double pole, double throw relay, that's exactly what this kind of contact is. These three wires, a red, a white, and a green, are 1 pole. And this other set of cables, which are the same colors, red, white, and green, are another pole. And you're going to have a common, a normally open, and a normally closed on each pole. And I'll show you how to test that. All right, guys. So as far as door contacts are concerned, the normally energized state, or its normal state, is when the door is closed and the magnet that all these come with is lined up with the door contact, right? So it would look something like that in a door. This would be usually in the frame. This is in the actual wood part of the door. When the door opens, this moves away, which tells whatever system you're working on that the door is open. So you need to meter or use a multimeter to measure all of these or tone these as if the door was closed in this state. So that's what we're going to do right now. Use our multimeter on the continuity setting. We'll put that here. Give it a test before we start. Yep, works. We'll put 1 lead or 1 wire on this lead, 1 wire on this lead. So as you can tell, there's no tone right now when I line up my magnet. So this would be considered a common, normally closed when the magnet's here. When the magnet moves away, the little reed switch in here, once again, it's like a powerless relay. This is your power. You're creating movement in this relay with this magnet. So there we go. So there's your single pole, single throw. Our single pole, double throw. So we got 3 wires here. We'll be able to easily find out what is what, even with the magnet not attached. The best way to do that is start with your black wire, and we'll see which one of these. So the black and the red give us a tone without the magnet, which tells me black is your common, red is normally open, and that would mean that your white is most likely your normally closed. There's an easy way to test that. Go back to black, test all 3. Okay, there's our black and red. If we chose white and red, we get nothing, which tells me that the black is the common point. It's the point that doesn't move. So if I lay this down, put this on red, our alligator clips will come in handy. We use our magnet, the tone goes away. There it is, it's away. So now we'll move it from our red to our white, which we are thinking is normally closed. There's no tone. And there we go. So black's the common point, and the relay is shifting between the white and the red. So the white is the normally closed with the magnet present, and that's in the normal state when the door is closed. Okay, so that's your single pull, right? One relay, double throw. We got a normally closed and a normally open. Now we go to our double pull, right? There are two sets of contacts in here, two relays, and 6 cables. Each of these does the same. This 3 does the same as this 3 at the same time. So we're gonna do the same thing. You can tell we have a white, green, and red. One of those is common, one of those is normally open, one of them is normally closed. Let's arbitrarily pick white as testing for common. We don't know, we don't have an instruction manual. So if I touch white and red, I get tone. So white and red, make a tone. White and green, do nothing. So we can almost certainly say that green is not the common. So what we'll do now is that we will we determine white and red are something in open state. So we'll test red and green, and I get nothing. So the common wire that makes a tone is white. So white is the common. So we've deduced, now we've got the common. White is the non-moving point in our system. It doesn't change. What changes is the red and the green. So I'm going to assume when I present the magnet, this tone's going to go away. Yes. So red would be our normally open. And we'll test green here now. No tone right now. And I assume when I present the magnet, we're going to get tone. So green is our normally closed. So when this is presented, the read switch in here changes, and the continuity is shifted from white to green to white to red. White to green, white to red. And that's how your door contacts work on your access control or your alarm systems. Keep it simple, baby.